This is the Courtyard Theatre, the Royal Shakespeare Company's newest theatre. It was opened in 2006 to provide a main stage for the RSC while the Royal Shakespeare Theatre is transformed. But the Courtyard Theatre is also a laboratory where the designers of the new RST can test some new ideas before including them in the new theatre's plans. The RSC needs its lighting infrastructure to be as flexible as possible to cope with the artistic rigours of the repertoire season. Moving lights, which can be focused remotely, have become the industry standard. In the Courtyard's thrust format, the lighting rig is based on a traditional system of bridges and catwalks. Moving lights have to be rigged under the bridge, and this presents problems for the lighting teams. This is lighting technician Lauren Watson.
Even though there are traps at the bottom of the bridge, I have to dress up in a harness and hard hat and lie flat on my front and stretch to try and change the bulb. Sometimes I have to get up the cherry picker to change the lamp, which can take up to 20 minutes.
So, why not rig the moving lights on lightweight portable structures which can be lowered to the floor? Wouldn't that be safer? Here's Vince Herbert, the RSC head of lighting.
Right at the very start of the design process, we decided to entirely base the lighting infrastructure around health and safety. With the way moving lights were coming into the business, we believed that we could almost entirely eliminate the need for ladders, taller scopes, cherry pickers, bridges, and maybe even PPE. We discussed a system of very lightweight modular truss, each part of which could be raised or lowered independently. I'm very grateful that Charcoal Blue are the consultants on this project. They were able to instantly see the advantages of a rig like this and help us take it one stage further.
The RSC started work to develop these structures and gave them the working title of lighting clusters. But there was still a problem. When a moving light is panned or tilted, it generates swing. In fact, the structure can swing for up to 10 minutes after the cue sequence is finished, which is why moving lights, until now, could only be hung from solid structures. Here's Vince again.
I knew it would swing, but I was very surprised as to how long it was swinging for. It made the thing almost totally useless. We had two options: abandon the project completely and install bridges, very much more expensive, or find some way to stop the swing. I started playing around with a few ideas and eventually came up with a prototype. Amazingly, it worked first time. We had set ourselves the goal of stopping the structure from swinging in half the normal time. We soon realized we could stop it from swinging in under 2 seconds.
After 3 years of research work, the Light Lock was developed. The RSC was in the lucky position to be able to put together an extremely talented team to take the Light Lock to its next phase. So how does it work? In operation, the Light Lock has 2 states, passive and active. In its passive state, the Light Lock continually monitors the structure on which it is rigged to ensure that it is absolutely still. When movement is detected because of the repositioning of a moving light, the Light Lock becomes active and the movement of the structure is instantly stopped. We asked the lighting designer, Tim Mitchell, whether he thought the Light Lock would speed up the lighting process.
Here at the RSC in the Courtyard Theatre, quite a lot of the moving lights in particular are underneath the lighting bridges and are not accessible very easily. So people have to get into harnesses, you have to try and haul the light in on a rope. It takes time, possibly 20 minutes to half an hour to change a unit over. Whereas with this system, it takes minutes by just pressing the button and bringing that light in, and you can change it within 5 minutes, swapping the whole unit out. For instance, I've lit a production of Dirty Dancing, which is now in 5 different countries. Because we have lots of things flying in and out during the show, it requires lots of the lighting bars to be split. So there are many pipes split across the whole length and breadth of the stage with just 1 or 2 moving lights on it. The biggest issue that I have with this is that we have to, at the end of the show, it's a big party number, and the lights move around a lot. They then all have to come back to a central point and be stationary. This is not easy when you have it just hanging on a single set. The light wobbles around a great deal. To do this on our current show, we have to run thin gauge aluminium scaffolding up each steel wire to try and take some of the whip out of the bar. It's not a very elegant solution to this, and actually doesn't stop it completely. Whereas with this solution, it stops it wobbling around, which is of a great advantage when you want a light to move quickly from A to B and then be stationary when it reaches B. At the moment, you're left with very inelegant solutions to this, and I believe this product does that.
But how does it really work?
I can't tell you that at the moment because we have the UK and international patents pending. I can, however, tell you that we've got some very sophisticated electronics in there and some complicated computer coding. One component is even from a children's toy.
You could say it's child's play.